Antennas are a vital component of modern technology, allowing us to receive and transmit signals for communication, broadcasting, and radar systems. While you may be familiar with the term antenna, have you ever wondered how they work or how they receive signals? An antenna is an electrical device that is designed to transmit or receive electromagnetic waves. Antennas come in different shapes and sizes and are used in various applications such as communication, broadcasting, navigation, and radar systems. 1. How does an antenna work? An antenna works by converting electrical energy into radiated electromagnetic waves and vice versa. When an alternating current flows through an antenna, it creates an electromagnetic field that propagates through space. Similarly, when an electromagnetic wave impinges on an antenna, it induces an alternating current in the antenna, which can be detected by a receiver. Signal reception is the process of detecting and interpreting electromagnetic waves that are transmitted by a source. In the case of communication systems, the received signal contains information that is encoded by the transmitter. The receiver decodes the information and presents it to the user in a meaningful way. 2. The basics of antenna design and functionality. An antenna typically consists of three main components: the radiating element, the feed system, and the supporting structure. The radiating element is the part of the antenna that emits or receives electromagnetic waves. The feed system is responsible for connecting the antenna to the transmitter or receiver. The supporting structure provides mechanical support and stability to the antenna. Understanding wavelength and frequency. Wavelength and frequency are fundamental parameters that describe the characteristics of electromagnetic waves. Wavelength is the distance between two consecutive peaks or troughs of the wave. Frequency is the number of oscillations of the wave per second. The relationship between wavelength and frequency is given by the equation: wavelength equals speed of light, frequency. Types of polarization and radiation patterns. Polarization refers to the orientation of the electric field vector of an electromagnetic wave. Antennas can be designed to have different polarizations, such as linear, circular, or elliptical. Radiation pattern describes the directional characteristics of an antenna's emission or reception of electromagnetic waves. Antennas can have directional or omnidirectional radiation patterns, depending on their design. Antenna gain and directivity. Antenna gain and directivity are measures of an antenna's ability to radiate or receive electromagnetic waves in a specific direction. Gain is the ratio of the power radiated or received by the antenna in a given direction to the power that would be radiated or received by a hypothetical isotropic antenna. Directivity is the measure of how focused an antenna's radiation pattern is in a specific direction. 3. Principles of signal propagation and reception. The electromagnetic spectrum. The electromagnetic spectrum is the range of frequencies of electromagnetic waves, including radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. Each frequency range has different properties and applications. How signals travel through space and matter. Electromagnetic waves can travel through space, air, water, and various materials, such as metals, plastics, and glass. The propagation of electromagnetic waves depends on the frequency, wavelength, polarizability, and absorption characteristics of the medium. Signal strength and attenuation. Signal strength is the amount of power that is transmitted or received by an antenna. Signal attenuation is the loss of signal power as it propagates through space or matter. Attenuation can result from factors such as distance, obstacles, interference, and absorption. Factors that affect signal reception. Signal reception can be affected by various factors, such as antenna location, orientation, height, and impedance matching. Other factors that can affect signal reception include atmospheric conditions, interference from other sources, and noise. 4. Types of antennas and their applications. Wire antennas. Wire antennas are simple and low-cost antennas that consist of a wire or a group of wires that are cut to a length that matches the frequency of the signal. Wire antennas are commonly used in radio communication and broadcasting systems. Loop antennas. Loop antennas are antennas that have a loop shape and can be made of a single wire or a flat conductor. Loop antennas are known for their high directivity and are used in applications such as direction finding, navigation, and radar systems. Microstrip antennas. Microstrip antennas are low-profile antennas that are made of a thin metal patch that is printed on a dielectric substrate. Microstrip antennas are used in applications such as mobile communication, satellite communication, and wireless local area networks. Dish antennas. Dish antennas are parabolic antennas that have a dish-shaped reflector and a feed horn that is placed at the focal point. Dish antennas are known for their high gain and directivity and are used in applications such as satellite communication, radio astronomy, and radar systems. Parabolic antennas. Parabolic antennas are antennas that have a parabolic-shaped reflector and a feed element that is placed at the focal point. Parabolic antennas are widely used in applications such as satellite communication, microwave communication, and radar systems. Array antennas. Array antennas are antennas that consist of multiple individual antennas that are arranged in a specific pattern. Array antennas are used to increase the gain, directivity, and bandwidth of the antenna system. Array antennas are commonly used in applications such as radio communication, radar systems, and wireless networks. Antenna applications in communication, broadcasting, and radar systems. Antennas play a crucial role in various applications such as communication systems, broadcasting systems, and radar systems. Antennas enable wireless communication between devices, provide navigation and tracking services, facilitate broadcasting of information and entertainment, and support various scientific and military applications. 5. How to optimize antenna placement and signal reception. Now that you know the factors that impact antenna performance, let's take a look at some strategies for optimizing your antenna placement and signal reception. Antenna installation and mounting techniques. Proper installation and mounting of your antenna is critical for optimal performance. Make sure to follow the manufacturer's instructions carefully and use the right tools and equipment for the job. Tools and techniques for measuring signal strength. To optimize your antenna, you'll need to know how strong the signal is in your area. There are a variety of tools and techniques you can use to measure signal strength, such as signal meters and smartphone apps. Antenna positioning and alignment. Once you've determined where to place your antenna, you'll need to position and align it correctly. This may require some trial and error, so be patient and use the signal strength readings to guide your adjustments. Strategies for reducing signal interference and improving reception. To improve reception and reduce interference, consider using a preamplifier or an antenna with built-in noise reduction features. You can also try moving your antenna further from other electronics and using shielding materials to reduce interference. 6. Troubleshooting antenna problems and signal interference. Despite your best efforts, you may still encounter problems with your antenna or interference with your signal. Here are some common problems and solutions to consider. Common antenna problems and solutions. Some common antenna problems include poor signal reception, interference, and damage or wear. In many cases, these problems can be addressed by adjusting the antenna placement or orientation, installing a preamplifier, or replacing damaged components. How to diagnose and fix signal interference. If you're experiencing interference or noise in your signal, there are several steps you can take to diagnose and fix the problem. These may include adjusting the antenna position, reducing interference from nearby electronics, or using a noise reduction filter. Technical support and resources. If you're still having trouble with your antenna or signal, consider reaching out to technical support for assistance. There are also many online resources available, such as forums and tutorials, that can help you troubleshoot and optimize your antenna system.